pretty abstract, so it's hard to show them in code and actually see a seam. There's no visualization really of a seam in code. So. Okay, so what is a layer? A layer is a group of reusable components that are reusable in similar circumstances. So a layer, we think of it like an N-tier application has a data access layer. It has a UI layer. It has maybe a domain modeling layer. So all these layers are components that are working in similar ways, and they may be reusable. So like a data access layer may have a, so they say you call them repositories, you may have a component called iRepository of T. That's reusable in the sense that you can implement that on customer, iRepository of customer, on invoice, iRepository of invoice, that type of thing. So a layer is very much it's a traditional concept. It's like tiering. So it's very much a horizontal slice in the application. So feel free to ask questions throughout this whole thing. We're probably going to end up just a little bit early today with this presentation. So these are layers. Your presentation layer, your business logic, your data layer. N-tier application definition right there. There's no other way to define N-tier really. That is the textbook definition. It's pretty simple. Three layers, 3 tiers. So we want to break down one of these. Business logic. It has many layers within it as well. So layering is a multiple level thing. So you see here inside of business logic, which is usually your middle tier in the application, you'll probably want to have a service layer. All requests to and data returned from the business logic or middle tier will go through the service layer. It's your entry point. You don't automatically come in from your UI and say, oh yeah, I want to work directly with the domain model. That's my entry point. Your entry point becomes a service layer. So through this, from the top to the bottom is how your code flows. Start up on the service layer, dribble down through to the domain layer, into the repository layer when necessary, and then down out of repository into your data access layer. So that's a pretty common architecture. How many of you guys are actually architecting in this type of format? So you got a few people who are. Are you guys are most of you working on N-tier applications then? Okay, you guys are gonna be all quiet on me. This is the way every presentation's gone. Everyone's quiet, and then about halfway through you start talking about stuff. So you had a question? The repository layer? So really, it's a service layer for data access, usually. So if you think of service layer as the entry point to your business logic area, a repository layer is entry point for data access, but it's just for controlling. So you may have, save invoice, or sorry, invoices.save or something like that on it, right? Invoice repository.save. Inside of it, it's going to make calls into your data access layers, and it may coordinate multiple things happening. Maybe you have to have an audit, a record entered into the database, and then the actual save or something, some combination of things like that. So it becomes a service layer in the sense it's coordinating multiple things happening for data access. That kind of makes sense? Okay, someone else had their hand up for something. Yeah? Layers in which? Tiers? Tiers are in a much bigger layer, or bigger scale, I find. So I wouldn't call this a 4-tier system. Tiers you're usually talking about they almost have more of a correlation with physical deployment, right? Your UI tier goes to the web server. Your middle tier goes to the application server. Your data access tier kind of maybe crosses over your database tier, certainly in its own server. But your data access tier maybe wraps up, sits over top of 2 servers, right? But it's more physically aligned than layers are. These live on one server, most likely. You could make the argument in some cases that data access might sit on a separate server, but usually in most applications, this would all sit on one physical server. Good enough answer? Okay, anyone else? Okay, so you can break this stuff down even further. Or no, sorry, there's more. Forgot about this. I don't usually do graphics, so I'm fading in and out, so I forget it. So layering and tiering as well are very much horizontal concerns, right? They go through your code in a horizontal swipe. But you also have cross-tier, cross-layer concerns, and some of them, like logging, might be vertical, right? So you'll have logging all the way through your application, but it is, in a way, a layer, right? It's an abstraction, it's a concern, it's just you use it in multiple places. So I consider it a layer within my code. We have these concept of translation layers that sit and overlap two other layers. So what they're doing, so in the case of a service layer, your UI will pass in a domain transfer object, which is just a stupid object. All it does is have properties on it, no behavior whatsoever. And it's passing in only the data that's required to make something happen. Same with passing out. So if you're listing customers on a page and you want to see first name, last name, street address, your DTO only has first name, last name, and street address in it. You don't pass your domain model customer object out, you translate it into the customer listing DTO object. So that translation layer overlaps two things. Same with the repository layer into data access. You'll translate your domain model, which goes down in, which is what dribbles into repository layer. You'll translate the domain model into whatever's necessary for the data access call. So maybe it's store procedure with parameters. Or coming back out, it's a data set getting translated into domain model objects, right? So you're translating one type of an object to another type. So slicing vertically, they can overlap, and then you also have slicing horizontally, and they can overlap, and you also can have a vertical concern as well, which acts like a layer. So we take one of these layers and look at it. This is the type of thing you'll see in it, in the repository layer. So someone asked about the repository layer over here. This is how I see repository layers working. You have that interface of iRepository, or some kind of interfacing on your class. What that allows you to do is decouple the implementation. So I don't care if it's customer repository or invoice repository or order repository, it is an iRepository, what I'm using. I can have two, maybe I have iCustomer repository as well. You can go, it depends on what you need. If I have iCustomer repository, I could have two implementations, both implementing the same interface, and they can be used interchangeably. If that allows you to set up this concept of an anti-corruption layer. So each one of these layers, while horizontally slicing your code, it can create a way for you to isolate those horizontal slices or groupings of horizontal slices. So if we go back to this, something like the service layer here, you may want to work on it and this whole grouping separately from the UI, right? You don't necessarily want to affect the UI when you're working in here. So you can create an anti-corruption layer right up here. That'll allow you to work everything down here, modify it at your will, but the interface exposed for the UI to work with up here doesn't change. As a result, you don't have to touch your UI code, right? You don't, if the UI is calling customer service in the service layer, it doesn't have to be modified to change save. Customer service.save takes in a customer DTO object, or customer saving DTO object. I can change how saving's done, how the domain model's working, what the translations are, without ever affecting the UI. The UI still populates customer save DTO exactly the same, passes it to iService or iCustomer services exactly the same. So that's an anti-corruption layer. Most likely you'll want to have them between each of the tiers, right? Each tier, UI, business, and data layer, you're probably going to want to have a minimum of anti-corruption in between there. You can also create anti-corruption in each of these. So the translation is actually a way of implementing anti-corruption. I don't want my domain model changes to affect the service layer. I don't want my domain model changes to affect the data access layer. So I'm translating the objects, and a translation means that I'm working with something different, and it can change, but the object that it's translated to or from doesn't get affected by it. Just the translation object down here would, and this translation layer may. but what's up here wouldn't necessarily change. So anti-corruption is a huge concept that gives you flexibility to change some things, but not affect a ripple effect throughout your code. Sorry, who had a question? Nobody. Yes? Yep. Yeah, understand what?
Regarding domain model and repository.
Yeah. Sure.
Until the data reaches the domain model, it doesn't know anything about your entities.
Yeah, so until it gets put into the domain model, it's dumb data, right?
You explained a little bit about repository. Can you go back to the slide? It talks about high customer data, but the data has not been modeled yet. So
So the repository layer is down lower, though, right? The repository layer is down here. So it's been modeled. So it's coming in a dumb object up here. It's been translated or inserted into the model in some way. So we've modeled the data to represent our business domain model. And then that is what's getting passed into the repository layer. So it has been modeled by the time it gets down here. I've seen on really anemic models, so there's a concept of an anemic domain model. I've seen people actually just skip around it. So you pass in a DTO, and they go straight to here with the DTO. And you lose the skill and the power of modeling there. So the domain DTO objects don't have any richness to them. They have no behavior. And applications are about data and behavior. Right? Our business, a lot of times we think of applications just data, but it's data and the behavior we take on the data. So the DTO has no behavior, the domain model has all the behavior, which is business logic and things like that. So if you skip around the domain model, you lose all the behavior stuff, all the business logic, but usually you trickle down through and you are modeled by the time you hit repository layer. There's no need for modeling at the service layer. Service layer is just a traffic cop saying you must do step 1, step 2, step 3 to complete this service request you've made. Does that answer your question? Yes. Okay. Gentleman over here raised his hand slightly too. Okay, dependency injection becomes pretty important in this, doesn't it? That's a primary way of doing it, yep. So what you end up with is you end up saying, in the service layer, what you'll do is you'll bring in a DTO, you'll model the object. The next call in the service layer may be to call off to a repository and say, so the first thing you do is you create your domain model object, then you say repository.save, you pass the domain model object into it to do the saving. And then when you've done that call, it's actually inside the repository.save, you're actually down in data access doing the save. So in the service layer, to be able to call repository.save, dependency injected is usually the way you do it. That loosely couples things. So you end up with, if you're doing constructor-based dependency injection, you inject in an object of type iRepository or iCustomerRepository in the constructor of the service layer object, and then make the call. So domain model is not like a DSL. So DSL is domain-specific language. The domain model is a collection of classes that have behavior and relationships among the classes. So what you're trying to do with a domain model is create ubiquitous language, which is the way that the business works and talks. So if the business calls it an invoice, you have an object called invoice in your application. That's ubiquitous language. The domain model is just classes. So you can have an account class, a customer class, an invoice class. You'll have one of the main primary concepts in domain modeling, or DDD, is You have an aggregate route. So depending on your business, your aggregate route might be a customer. Everything falls off of customer. So customer has invoices, customer has addresses, customer has history, customer has credit reports, things like that. So it's not a DSL, but it's rich in the sense that it represents the business functionality, the business terminology, and the behavior that occurs within a business. The top translation layer is really a way of taking those dumb DTOs coming in from the UI, where maybe all you're passing in is customer ID or something like that, because they want to display. You clicked on a grid row that says bring up the details, so you click on it and all you do is pass in the customer ID so you can load up the customer details to display on a grid. It'll actually, that translation is just taking that ID and creating a domain model or loading up a domain model object based on that ID value. So it's not translation in the sense of converting it from one value to the other. It's translating from DTO to domain objects, loaded objects. You could do DSL, yeah. I mean, really the whole modeling thing in the domain is creating business rules, right? So DSLs can be used for creating business rules. But what you're doing is you're using a DSL to create a domain model. They're not interchangeable. You're using one to create the other. So, is that okay with you? You don't seem like you're convinced.
What is the best way to bring the translation layer?
So the translation layer is just a bunch of classes that do converting from one to the other. My common pattern is I have an iTranslate. I translate source, destination, generic. So the source and destination are my generics on the class. And then I have one method off it, which is from. So I can do customer to customer listing DTO translator dot from customer. And it returns back a customer listing DTO or an iList of customer DTO type thing. That class is only concerned with doing the translation of one object at a time. So if I need to do a listing of objects, so an IEnumerable of customer into an IEnumerable of customer listing DTO, I have to, somehow I've got to get it looped over and call that many times to do the translation and creating the objects and passing them out. That kind of makes sense? Sorry? Generic list, yeah. IEnumerable of customer listing DTO. So a list of T inherits from iList of T. iList of T, it doesn't matter if it's a list or if it's an array or if it's a collection or whatever it is, right? It is the base of everything. You can use it for doing custom listing as well, but if I just return IEnumerable, it could be a list that I pass back out. It doesn't care. So the implementation of the type of collection that your object is holding is not exposed to the front end or to the calling code. It just says, hey, I know I can get something I can loop over. That's what you get back from it. So I've just started moving to using iQueryable of T instead of IEnumerable, but just started doing that. So that allows you to do a little bit more link-esque type things with it. A little bit more, not a lot. Workflow? Workflow is usually business logic, right? It's how your business works, it's action. So it would sit somewhere around the domain model, somewhere, probably just above the domain model. So you're not modeling the business as much as you're modeling the actions, and workflow would usually pass around information that is in and out of the domain model. So Windows workflow, I've never used it, so I've never had the problem of trying to figure out how to get it in there, but that's where I see it myself, is basically, it's happening kind of in this area here, kind of. But what it may be doing is like a workflow is just doing a sequencing of events. So if you're building a good service layer, your workflow might actually sit up above the service layer, where it makes calls. It say, hey, I've got to do X, Y, Z. So it calls the service layer and does some stuff, gets returned to value, and then it says, oh, next step I've got to call, ABC, calls the service layer, does that. So it may very well sit right above the service layer, and you treat every service as an atomic unit of work, which is a node in your workflow, right? So it depends on how you're working things. Like that, putting it up above the service layer is more of a SOA concept. Yeah, so yeah, that would be like a SOA or a BizTalk workflow above your service layer, yeah. Okay. So I would actually put that workflow into my service layer probably, because I consider my service layer as the organizer of what things have to be done. So it would go somehow, it would work into the service layer where you call I don't know, invoice approval service, right? And it would say, okay, what are the steps I have to have done? And the steps may be you know, check status of the invoice, then make a decision off the status as to what it needs to do, and then once it's done that, it'll be once it's done what it needs to do, it may update the status as the third thing. I consider that service level functionality. It's organizing, coordinating what things need to happen when, in what order. You can have the domain model, yeah. So this is actually just how the layers stack above each other, but inside the service layer, up here, it's just coordinating things so the domain model object, customer, will be available there. Customer, you can do repository.fetchById 1234 and get back a customer, and that customer is available in your service layer, but you don't do anything with it, you just pass it off to something else usually. So, that makes sense?
And where does your transaction start?
My which?
Transactions.
My transactions? Transactions are really hard to figure out where they should and shouldn't start. I consider every service entry point to be a transactional component myself. So if I'm doing something like system.transaction concept, I'll try and have it in the service layer. Because if there's 2 or 3 things happening, it'll be, you know, saving to the database for a customer, saving to this, saving to that. Three different saves happening in the service layer. They'll be explicitly declared in the service layer, so I could wrap those 3 different things in a transaction. Personally, I use Hibernate all the time. I allow it to take care of my transactioning for me. So, somebody else had raised a hand over here, I think. Yeah.
When you have a workflow and it goes on what if it goes on a business rule? What if it goes on a set of business rules?
So then you're talking about generating the workflow through decisions based on or values that are present in the model, probably.
You don't have a business model for it, a domain model for it.
No, you'd have a domain model for your business, though, and the information that's in your domain model would be used to figure out the workflow.
Spans across different domain models.
Oh, wow, yeah. So, yeah, okay, one thing to think about, domain model is not, it's a concept for how the business is represented for your application. Rarely will you have the same domain model in multiple applications in the same business. I've never, ever tried to deal with workflow amongst multiple domain models. I would think at that point you're talking about enterprise level, so like BizTalk calling services from multiple business or multiple applications or something like that. Honestly, I've never done it, so I couldn't give you a solid answer, but that's what I think you would do. So. Any other questions right now? Yeah, sure.
The transaction there is something which has a lot of manual code.
Yeah, it can have a lot of manual code, yeah.
I go down that kind of project where it's a lot of manual input is going, they start inputting from one side to another side.
Yeah.
Is that a good model?
So if you're usually you're not doing straight across translation. So if you're getting in 3 properties on your DTO, you're probably not doing 3 properties onto your domain object. Usually you use those 3 properties to load up or to call a repository to load up your domain object. Yep. That's translating from, so maybe property 1, property 2, property 3, those are going into, or the other way around is probably a better example. You're getting a data set back or a iData reader back, and it's got 4 columns in it, and those are getting applied into properties in the domain model. Yeah, that's a perfect example there. So there's 2 ways to do it. One is roll the code by hand, or there's 3 ways. Roll the code by hand, use an ORM, where you just configure it to say how to do the mapping and load it for you. And the third is to do reflection-based. I prefer the ORM method My second choice would be to roll it by hand. My third choice would be to do the reflection. The reason I don't like reflection is that the only real way to do reflection on it is to have the properties on your objects match the names in the columns of what you're getting back. To me, you're too tightly coupled between your database and your domain model at that point. You change something in the database and you screw yourself on the translation into the domain model. So too tightly coupled. So that's why I choose ORM's really good, because it's just configuration for NHibernate, it's XML configuration of what's the column name, what's the property name, done. If I want to change the column name, good, I change the column name. If I need to change the table name, I change the table name. Nothing inside my C# changes, right? So that's an anti-corruption layer in and of itself right there. So, anything else we want to go over on this slide? Okay. So we were back at looking at the repository layer. So this is the kind of thing I see in the repository layer. This has actually changed. I changed my mind since I wrote this slide on how I like things. To me, this is like the personal growth and always challenging my assumptions. Somebody the other day was talking about how they build their repository layer. I've always built it with a naming structure like this. They were saying, don't call it customer repository, call it customers, the plural of the object. So now I've got customers.save, customers.fetchById, customers.loadAll, something like that. It reads a little better than customer repository.loadAll. The word repository isn't necessary. It's assumed it's a repository because of the namespace it exists in. So, but this is how I basically see things happening. You have your concrete objects, and then you have your interface that all of them implement at some level. They might not directly implement iRepository. Like you might have an iCustomer repository that implements iRepository, and customer repository implements iCustomer. So you do interface chaining to get your implementations. And this is just a repository layer example. Service layer, I would do very, very similar. I would have something services, and then I'd have customer services that implements customer services that implements services, something like that. So again, it's creating these layers and seams through the use of interfaces, dependency injection, things like that, to give you good anti-corruption and good isolation of your code. So if you're going to start putting this into your code, you guys all go back to work next Monday and you say, right on, we're going to do layering. We're going to start doing all this stuff. First, it takes a while to do. It's not an easy refactoring in your code. Second thing is that you will see some great side effects. The replaceability one is awesome because everything implements an interface. So you have iCustomer repository. All of a sudden, I want to change. My customer repository stuff needs to change somehow. Maybe I'm not saving to a database anymore. Maybe for some reason I'm saving all my customer stuff to a file. So instead of having a customer repository that implements iCustomer repository, I can have file-based customer repository, which implements iCustomer repository. Rest of my code doesn't know about it. I've just done replaceability. I've just replaced one method of saving and persisting data with another method. Reversibility, same thing. If I have customer repository and file-based customer repository, all of a sudden file-based customer repository doesn't really work for us anymore. We decide that it's too slow to persist data to a disk in a text file and parse it all because it's comma delimited. We want to actually use a relational database. I can just go back to my other one and use it. So if I'm doing dependency injection with an IOC container, I just have to change the configuration of my IOC container and replace file-based customer repository with customer repository. I've just changed the functionality of my code without affecting anything throughout the application. So that type of replaceability and reversibility is really powerful if you've got a lot of flux in your code. Even if you don't have flux, we always have change. We want to do something different. One of the core concepts of OO is the open-close principle. That states that a class is open for change, or no, open for extension, closed for change. I don't want to go in and change my customer repository. I want to extend it. So I want to do a decorator pattern on it, maybe, or something like that. where I wrap it with another class, do the extra functionality, and then delegate off to the original class that I had. Where was I going with this? Sorry, I completely lost my train of thought there. So open-close principle is that you want to extend, blah, blah, blah. Okay, so you'll do that. So now instead of just going in and changing customer repository, I've created another class, and now I can just use it. It still maybe implements iCustomer, or probably implements iCustomer repository, but I can use it in place of customer repository instead. Very, very easy to do that, to add functionality, not breaking the open-close principle, OCP. So that's great. Cohesion, concept of cohesion is that you have, your code is very knowledgeable about what it does, but not knowledgeable what other things do, or not overly knowledgeable about what or how other things do their business. Having layers and seams forces you to make sure that whatever's in that layer is not jumping over the seam and too knowledgeable about what's below it, right? It knows how to call it perhaps, but it doesn't know how it does things inside of it. So you get a much more cohesion within your application. Again, that reduces brittleness and it increases the flexibility in your code. So any questions about the side effects? But these are things that you can really take advantage of. If you're doing dependency injection, you increase your testability, right? You can start doing mock testing. So how many are you familiar with interaction behavior-based testing using mock objects? So no one's using Rhino mocks, nmock, type mock, none of those things? You've got a couple people that are using them. So what that type of testing allows you to say, when I call method X, did it delegate off to another class, another method on another class? And when it did delegate, did it do it a number of times I expected to? Did it pass the parameters I expected it to? That type of thing. If those things don't happen, your test fails. So you can set up a test to verify the interaction between two classes or multiple classes, which is really important. So if I've got a service layer, and the first thing it does is it calls off to the repository to load up the customer object and all its child objects. Then it calls the customer object that was returned and it calls a method on it. And then it takes that method does stuff, it modifies the customer object in some way. The next step is to call back to the repository, passing the customer object into a save method. So three things happening there. But you need all three things to happen. You want to write a test to verify that all three things happen. Maybe even verify that they're happening in the right order. But certainly to verify that they happen. So you can, with dependency injection and mock-based testing, having that nice layer there allows you to do this by injecting a mock object and setting up expectations on the behavior that it occurs with it. That's a whole presentation in and of itself, though, so we're not going to get too deep into that. The lower coupling is, again, it boils down to layers not knowing what's going on in other layers, and having interfaces built into everything. It allows you to do replacing. So you're not coupled to a concrete class. You're working with an abstraction. And the adheres to SRP, I find that having layering, especially like the translation layers and things like that, it takes things out of classes that they shouldn't be in. So you don't have the service layer translating a domain object into a DTO. You don't see DTO property equals domain property, DTO property. That type of thing doesn't exist inside your service layer. It's delegated off to another class. Single responsibility for that class is to translate. Single responsibility for the service layer is just to coordinate the steps that are happening. Layering is a really interesting concept. It's the same with the tiers. The traditional way in .NET that you manage tiers and layering is through the use of projects, right? We've all built our projects, and Microsoft has kind of created this edict out of them in the past of, you have a data access layer project, you have a web UI project, you have a business logic project, things like that, right? Every project represents a layer, in essence, or a tier, depending on how granular they've made them. I personally, I think it's great. That's one way of doing it. Really, all you're doing is driving your projects to be namespaces, though, right? So your project becomes mycompany.myproject.data access layer, mycompany.myproject. business logic or domain or mycompany.myproject.services, something like that. Really, all it is a way of grouping your namespace. But you can group your namespaces inside one project, right? You just add subfolders inside your project, or you can just manually add a namespace as you desire to a class. You don't have to split them out into multiple projects just to get the namespacing, because namespacing is important for organizing this stuff, right? You don't want translation object sitting inside of a translation folder and another one sitting inside of a domain model folder, another one inside the service. You want to organize them so they're all in one place. It's easier to navigate your code, easier to manage the code and what's going on. So Microsoft's edict of having one project, one project per tier or layer really ends up resulting in one assembly per tier or layer. So you end up with mycompany.myproject.dataaccesslayer.dll, mycompany.myproject.whatever, right? You have one DLL per assembly or executable depending on the type of project it is. That's what happens coming out of there. You don't necessarily need to have an assembly per layer though, right? If we go back to my slide there with all the layers on it, I might not want one for every one of those layers. That's really just a way for me to logically organize my code. It's not necessarily a physical deployment model though. My physical deployment model might be more related to this. I might need to physically deploy to 3 different servers. But I don't need to have one assembly for, on this server, one assembly for data access, one assembly for business logic, one assembly for whatever the other one, service layer, all those types of things. They're all going onto one server. Maybe I can put them all in there as one assembly. But if you do one project per layer and you build out of Visual Studio, you're going to end up with one assembly per logical layer, which means you're going to deploy 4, 5, 6, 8 multiple assemblies to this layer here. You might do the same here. You might do the same here. You're increasing your deployment overhead by having multiple assemblies. So what you end up with is the old way. I don't know, is that relatively visible to you guys, what's going on in that image? Can you see it? Sort of? Okay, so what we've got here is we've got our business logic. Oh, that almost was bad. You got your business logic project, you've got a data access project, and you've got a web services project. 3 projects. Each one of them, business logic project has a domain, it has translators. Data access will have a whole bunch of stuff in it, right, for managing your connections, all that kind of stuff. And your web services will have all your SVC, or if you're doing, not ASPX, but SVC, which is WCF stuff, right? You'll have all that stuff down inside your web services. That's kind of the old way. You end up with one assembly per layer in that case. I don't like it. That was what the red X was for. So this one here, why not have one project inside the solution? And then we can logically break it up. I've got my domain layer. I've got an infrastructure vertical slice, right? That contains my logging, any other aspect-oriented type stuff I may do maybe inside of there. I've got my repositories layer. I've got my services, I've got my translators, I've got my DTOs. If I compile that in Visual Studio, I get one DLL. That doesn't work for my 3 DLL deployment, right? Or my 3 server deployment. I can't deploy that, I probably don't want to deploy that one DLL to every one of those servers and have code that's not required or shouldn't ever be executed on those servers. So what you have to do is you have to compile it, compile it outside of Visual Studio into those servers. But I've still got my namespacing, so I can compile based on namespacing. I can say in my business application server, I want to have domain, I want to have logging, and I want to have translators in there. So I compile it to have those 3 things. On my UI, maybe I have UI DTOs, and it doesn't show up in there, but maybe I have web pages or something else like that, right? I compile all that stuff into another one. Data access, I might have my repositories, my logging, and my domain objects into that DLL. So I compile it as I need for my deployment. All the namespaces is still there. This is just organizing it. It's organizing it differently than this. That's all you're doing. Different organization. But it gives you, it reduces the number of projects you have. It reduces the clutter in your Solution Explorer. It speeds up loading of Visual Studio. I worked on a project that had 56 projects in the solution file. Took forever to load Visual Studio. Apparently, since I've left there, one of the guys has gone through and they've reduced it down to something like 16. Visual Studio loads in about a third of the time that it used to. Same number of files, same amount of code, but the speed Visual Studio initially starting up increased significantly. So it's just an organizational thing, right? So that makes sense what we're trying to do there? Why we're talking about that? Doesn't make sense? Why, what doesn't make sense? Okay.
Now, the reason why they have different projects for each of these, for example, the domain of this project, is that they're able to use in various modes. So in a standalone application mode, in a web service mode, and there are several different modes in which they use the same assemblies. So you need to build the assemblies once, and then you can reuse them across different versions of the application that different people are using.
Yeah.
So in that case, having each of these layers in separate assemblies makes sense. So it means I need to have separate projects.
But so you're talking about different application front end, right? So maybe you've got a mobile application, maybe you've got a web application and a WinForms application. Fantastic. This here is the guts of my program, right there, right? I'll have another project for UI, web UI. I'll have another project for mobile UI. I'll have another project for WinForms UI. Very, very thin project. Everything from that project, all it does is coordinate workflow from the screens and whatever UI DTOs are needed to pass down to the service layer or come back from the service layer within this. Same assembly can get pushed around. Has the same code, the same core. You want that same business logic, right? You want the same workflow on each one probably. Everything drives through this. You just throw a different UI on top of it. So a great thing about having the layering is you're saying at the level of the services layer, which is my entry point for all applications, doesn't matter what my UI is above that. It just knows the UI has to pass me customer ID if I want to bring back the customer edit DTO. Whatever it does with the customer edit DTO, who cares? That's the screen. That's what the screen does. You know, it passes back the ID, passes back a updated customer DTO. It passes, all I know is that updated customer DTO object's coming in. I do all the logic around or not all the logic, but I do validation of it. I pass it down into my repository for saving, I translate, whatever. I do all that stuff, right? Always happens the same then. But you just throw a wrapper, a UI wrapper, or UI. UI is really like a wrapper over your service layer in that case. That make sense?
But the word I want to make more sense in that case.
Okay.
Because I have, let's say I'm building a smart client, then that means I have a proxy, and I have a UI.
Okay, in the smart client application.
So the older model actually makes no sense because you have different projects, and each of them is responsibility. Rather than building the whole thing as one big assembly.
It doesn't have to be one big assembly. It doesn't have to be. This is just for organization of the code in the IDE. So this is a big leap over the way of one project per assembly, or per concern is what you're really saying. Not responsibility, but concern, I think. That old way, on this previous slide here, this here is very, very clear what your assembly, what your concerns are, right? It's because your concern is a project. If we go to the way that I propose and the way I use, your concern is a namespace. You don't deploy that as one giant assembly. You still may deploy your assemblies in this manner, one assembly per concern, but you don't do that and reflect that in your application, in your IDE. You reflect that in your build script. So it's the same thing in the end, right? You probably end up with the same thing. You might end up with less assemblies. You know, one of the things I'm exploring myself is using one assembly per physical server. So this here, you wouldn't end up with one assembly per physical server. But if I do the other way and compile with my build script, I could make it so my build script just says one assembly per physical server is all I get. So does that clear up the question? I mean, there's no right way to do this, right? It's just the way that I propose that I do it, and it's a way that I get around This is a way I could really show layering and how it works. So if you want to talk about it more after, we can definitely have a good conversation about it. Sure, sorry. Yep. So the problem, this is the risk you run, is in this one here, I run the risk of referencing the wrong layer at the wrong time. Oh, internals. See, internals are evil in my mind. So I don't use internals. I specifically have code that checks that I don't have any internal classes. I believe everything should be made public unless otherwise stated. And there's no reason for anything to be internal unless you can really give me a good idea. So all my code, I never do internals. I do publics for everything. I don't want to restrict the person that's consuming my code before I know that I should restrict them or before I know whether they need to use it or not, right? So that's my thing. It's a big argument and fight that people have with Microsoft and the way they build the framework. There's a lot of stuff that's internal in the framework that would be fantastic for us to be able to use. But we can't use it because they've decided ahead of time to make it internal and restrict our use of the framework. So that's why I don't do it, is I don't want to do that to the rest of the developers on my team or anyone coming after that's going to consume my code. But you're right, if I did do internals here, totally different effect on how the code can be consumed than the other one. You're right, you're absolutely right. But I avoid it as a rule. The problem that you can run into here, though, is that inside my service layer here, invoicing services, I can call something that I shouldn't call, right? Because of the way my layers are stacked, I can skip layers really easily. So instead of translating to the domain model and then calling the repository, I could just go straight through with my DTO to the repository because there's no reference restricting me. So in the other one, if I don't have a reference to DTOs in my repository project, I can't pass it through. It just won't compile, right? But here I don't have that restriction. I don't have a compile time check. I get around it by using a tool called ndepend and running checks using it against the code to say anything in the repository's namespace should not have anything from the UI DTO namespace. So but it is a risk, and you have to be very careful doing this. So if you have a whole slew of junior developers on your team, you're going to have some bad things possibly happen with this model. So I wouldn't, if I had 10 junior developers and me by myself leading them, I probably wouldn't do this. I would end up chasing around poorly organized code all the time. Anything else you guys want to ask or say? Tell me how wrong it is to do this? Feel free to tell me it's wrong. Okay, sorry?
I think that it's partial advantage by looking into multiple layers by redistributing it. You can.
It's a good argument. Yep. So the argument is that if I have it split out into 3 projects or assemblies like this, I can roll out to my server an update only to data access if I want to. How many times do you do that? That's my argument back to you. How many times do you do it?
I say that this might be required, especially in the regulatory, you say adhere, those kind of aspects.
Yeah.
You know that it is lesser impact, and you do the regression testing also gets reduced, and you just need to be able to lose.
Right.
That makes more sense.
Right. So how often do you actually do that in your work? Do you do fractional deployments on a regular basis? So this is my argument back to people, because I have had this discussion. But my point, and I hear this all the time, we need to have it split up because we're going to do fractional deployments in the future. You know, I work on project for 3 years. That was the argument on day one, to have things split up and how we organized our assemblies. Not once in 3 years did we do a fractional deployment. Yeah, no, it's cool. That's why I'm going back and forth, because this is a really good point that you're making, and why I argue against it. It's not necessary, but it is a thought. I talked to a gentleman. I don't know. I'm probably not pointing to the right guy, but I talked to a gentleman in here in my previous session about just that. He was doing fractional deployments across a very slow internet connection, and if you're doing that, you want to make sure you get all the files or none of the files. And a fractional deployment might reduce downtime on the server that you have and might guarantee that you're not screwing up what files are going over there. It is much, much more difficult to guarantee that your code on your newly deployed files and your existing deployed files work together without causing error. So it's a lot harder to do that. So, but yeah, it is necessary sometimes. I think it's way less necessary than people argue. So, anything else? Okay. So we've talked a little bit about this kind of stuff already. I've gone on and on about interface contract-based programming. Very important for decoupling. Allows you to do the replaceability of something that implements iCustomer repository with 1, 2, or 3 different reasons. Well, we were working with Pet Shop, a couple of the sessions I've done here, and Pet Shop has a concept of writing to Oracle or SQL. So it has 2 iCustomer repositories, essentially. One implementing for the Oracle way, one implementing for the SQL way, and then it has a customer repository factory that decides which one it should be using. So having an interface-based, contract-based programming gives you that flexibility. Dependency injection, we briefly touched on that. That allows you to, it's the Hollywood principle, don't call us, we'll call you. So don't tell me what to use, give me something to use in your code. Pass in the object I need to use. I need to translate from UIDTO to a model, or a model to a UIDTO. Give me the translator. I don't want to tell you which translator I'm going to use. Give me the translator I'm going to use. That's what dependency injection is. Inversion of control is really closely tied to dependency injection. Usually we talk about inversion of control with a container, and that container will take care of deciding what should be passed in when you say, I need that translator. It'll say, oh, here's the translator for you. Go ahead and use it. So you don't have to code up something to say what to use. It just works in the background and does that for you. So we could do a whole presentation on DI and IOC, but do you have any quick questions about it? Okay, yeah? So unit, oh no, unit test. You unit test every single piece of code that you should be trying to unit test every single piece of code. It may be state-based testing, it may be interaction testing, but you unit test everything. You unit test the service layer, you unit test the translator, you unit test the domain model, you unit test the repository, you unit test the data access if you want to as well. Interaction-based testing allows you to do that in isolation. So you can test the service layer without worrying about the fact, oh, it calls off the repository, you have to have data set up, all that kind of thing. Replace it with a mock object, and it's a dummy object that you can tell it what to return, so you don't have to worry about all the stuff below it being set up. You also need to do integration testing. So up at the service layer, call the service layer. That's a slow test though. It's going to go through and run all the code, hit the database, return all the code back, and you'll verify that first that it ran without throwing an error, and second that it returned the data that you expected, whether that be a count of records or the actual data that you expected out of the database, that type of thing. But yeah, you test absolutely everything in there. The benefit of all this stuff and using these types of things is that you can test in isolation for your unit tests. A unit test should test only a small piece of code at a time. And if you're doing all these things with SRP, SOC, that type of stuff, you're going to get a really small piece of code that's really, really easy to test. Did it call the repository? Done. That's all you need to test maybe. Or if it's a translator, I passed in a customer, I got back a customer listing DTO, did the properties translate? Is ID equal to ID? Is name equal to name? Whatever the translation may be in there. So you do those testing, but it's a very, very small test. They're very easy to write. They're very easy to verify. So, that answer your question? Good. For the testing?
Yeah, I mean, you have multiple layers.
Yeah. A lot of which, sorry? Yeah.
Right? So how do you bootstrap all this? It's data dependent now. I want to, let's say, query for a bunch of customers, ask them to the criteria, and I want to see whether I get that criteria.
So that's an integration test, right? That's a slow test. They take a lot of work. Slow tests are also slow to write. You have to make sure that you prime the database properly, the database is created. And you can't just say, oh, the database has data. You have to prime the database for every test so that you have the data in a state, an expected state that you can verify consistently against. So there's all kinds of ways to do it. I've seen presentations, like 2-hour presentations on that alone, so we could go really in depth. Transactioning is one way of doing it. So load your database up, prime it initially, transaction if you're doing updates and stuff like that, transaction it, roll it back so your database is back in its expected state. I see there's another one called DB unit. Yeah, DB unit, I think it is, which allows you to use XML configuration to prime the database before and after every test, things like that. There's just all kinds of ways to do it. But the end goal is to get the database set up in an expected state so that you can know that your verification in your unit testing or your integration testing will always succeed or fail, whatever the case is that you need, right? Okay, I was going to do a demo, but we only got 1 minute left. This is the slide I end everyone with. So if you've been in here before, this is just the thing. Look at this stuff with really a suspect eye. Go into your work, and if you want to implement layering, be very careful. Don't try and implement it all at once. Just do a little bit. Just say, oh yeah, you know, like I need layering in here, and just work at small steps at getting towards layering. You know, and creating those anti-corruption layers. Anti-corruption layer is probably the first place you want to go, but you know, look at it and don't try and jump in. Actually, look at it, evaluate even if you should with your code. I mean, you probably should overall, but is it a good thing to do with this code base right now? If your code is stable, it's in production, there's no ongoing development on it, maybe it's not a good thing to be doing right now. You know, you're not putting a lot of effort into it anyways. Why invest a month of refactoring just for that? That's all I've got. So we'll be, I'll be out tonight at this champagne and cheese thing that's somewhere. I'm not sure where it is, but if you want to talk about this stuff, feel free to grab me there. We can go through it. I know it sounds like you guys up there got some really good questions about it, so if you're going to be there, grab me, we'll talk about it. This has been awesome. This is my last presentation here at the conference. It's been great coming out and seeing you guys and the passion that everyone in this community has. It's great. I hope I get the opportunity to come back and do this next year. So thank you all for that. It's been really inspiring, and enjoy the rest of the conference.